All right, we're going to start down at the bottom of the front page where it says exponents. The exponent rules. You've kind of done some of these before and some might be slightly new. At any point during today's lesson, if you want to get up to go get a calculator, you sure can. Can you put your Chromebook away? You don't need it? Some of you have your phones out. Let's put them away. We've got notes to do. Take your earbuds out. The first blank, anything to the 0 power is, no, 1. So what would 14 to the 0 power be? Nope. And if y'all don't know, get a calculator. What is it? 1. What is -5 to the 0 power? 1. What is 152.3 raised to the 0 power? 1. Anything to the 0 power is 1. So don't break your brain trying to think about it. Anything to the 0 power is 1. If you don't believe me, grab a calculator. Let's test it out.
Well, I'm wondering why. In math, why does that occur?
It has to do with logarithms.
I'm not gonna. So I'm really good at that.
Okay. Negative exponents, and it has to also do with you can't start with nothing. So negative exponents can be rewritten as, so the 2 has an exponent of 1, but the x has an exponent of -3. So we can fix that by writing it as the 2 is going to stay on top, but the 3 can go on the bottom. And now that exponent of 3 is positive. So you can change the side. It can either go on the top or the bottom. So now if I have the same thing, the x to the -3 is on the bottom, so I can rewrite it on the top and it will be positive now. The 2 stays on the bottom, but I can rewrite the x and it's positive now. So moving it from the top to the bottom or from the bottom to the top can change the sign of the exponent. So the next few things are when the coefficients are adding, subtracting, multiplying, dividing, or you raise it to a power. So the coefficients are the numbers in front. So here. So that's like 4 minus 2. Boys, put your phones away. We're taking notes. So here, this is 4 minus 2. Those are the coefficients. So when you add or subtract the coefficients, the exponents do nothing. So my example, if I have 4x squared and I subtract 2x squared, well, the coefficients are subtracting. 4 minus 2 is 2. The exponents do nothing. It stays squared. Because you can only subtract or add if the exponents are the same. When you're multiplying, so here, this is like 5 times -3. So when you're multiplying coefficients, you will add exponents. So 5 times -3 is -15. And then for the x's, I have 3 and 2. You don't multiply them together. You do one less operation. So this is 3 plus 2 or 5. Okay, when you add or subtract, you do nothing. If you multiply, you will add. When you divide, what do you think we're going to do? Subtract, good. And more specifically, we're going to subtract to the bigger one. And that'll make sense once we do the example. So when I look at my coefficients, I have a 4 and a 2. Well, 4 divided by 2 is 2, so that number is going to become a 2. And then for my exponents, I have a 2 on the top and a 3 on the bottom. Well, 3 is bigger, so this one's going to come down here and you will subtract 2. So I get x on the bottom, 3 minus 2 is 1. I don't have to put to the first power. For my second example, I'm still dividing. 3 divided by 6 becomes 1/3. And for the exponents, if I look at the exponents, on the top I have 5 and on the bottom I have 3. So I'm going to subtract towards the smaller one, towards the bigger one, towards the bigger one. So I have 5 minus 3, or a 2. Otherwise, if you just always subtract to the top, like this one, if you had 2 and you subtract 3, you end up with a -1 and you'd have to bring it down anyways. Because usually we want answers to be with no negative exponents. So the last part, when you have coefficients that are raised to a power. So this one, the 5 is raised to the power of 2. The exponents are going to multiply. So this exponent distributes into both pieces. So I end up with 5 squared, and then the exponents multiply. So it's 3 times 2, or to the 6th power, which is the same thing as 25x to the 6th power.
Does that make sense?
I decided to reset everybody's score, so nobody has a score yet. Well, they just did theirs last period. They turned in. Name something you might make out of coconuts if you were stranded on a desert island.
Puffs?
What?
Puffs?
Sorry.
Water? Oh.
What would you use a coconut for? Very good. Gotta have a bunch of coconuts. What? Come on, these are gonna be so obvious. Oh, that's a good one. Oh my goodness, you just said that too. All right, we got some more notes to do. So on to the back of the notes. So these say simplify and rewrite without any grouping symbols or negative exponents. So for this one, how can we rewrite that and it has a positive exponent? Yeah, we have to rewrite it as a denominator. And what's 5 squared? 25. So it's the same as 1 over 25. For the next one, we might need a calculator. But it's the same thing as 3 times 3 times 3 times 3. And we can do these in groups. What's 3 times 3? So 3 times 3 is 9. What's 9 times 9? 81. The next one is -4 times 3. So we have -4 times -4 times -4. So when we multiply these out, what's a negative times a negative? What? It's just multiplying. -4 times -4 is positive 16. And what's 16 times -4? It's going to be a negative. What's 16? So the next problem, I am going to distribute in the -2 to both pieces. So we're going to kind of do this step by step. So it's still going to be a negative, and it's 1 to the -2 power over 3 to the -2 power. Anytime you have a negative exponent, remember you can rewrite it on the top or the bottom. So those need to switch places. It's still negative. So I'm going to switch it. So I got 3 squared over 1 squared. So now they're both positive exponents. And now I can evaluate them. What is 3 times 3? 9. And what's 1 times 1? 1. It's the same thing as just -9. Because I have had a negative exponent here, so I need to rewrite the 1 on the bottom. I have a negative exponent, so I need to rewrite it in the top. So anytime you have an entire fraction that's raised to a negative exponent, one thing you can do is just flip it. You just apply the reciprocal. The next two problems have us just adding or subtracting. We've already done these problems before. We've done them already before, but we're doing them again. So when you add, is there any reason to have parentheses around the second set? No. So all I'm doing is combining like terms, really. So 3x minus 5x squared plus 6x minus 8 plus 2x squared. All I'm going to do is go through and find the like terms. So I have an x term. Those are all the x terms. These are squared terms. So I can combine like terms. So remember, anytime you're adding or subtracting, what do you do with the exponents? Nothing, nothing. So I'm going to start with the biggest exponent. So I have -5 plus 2, or 2 minus 5. So I have -3x squared. And then I'm going to go to just the x terms. So I have 6 and 3, so I have 9. Three and 6. And then I have a lone 8 all by itself. And that's it. For the next problem, we're subtracting. Please make sure that you guys have your phones away and you are working along with me. The first set of parentheses, there is no negative out front, but the second set there is. So that second set of parentheses, I have to rewrite it, and every single term on the inside has to have the opposite sign. Looks like they're all positive. Positive, 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 positive. So they're all going to change to negative, 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 negative. So I'm going to rewrite this. That's not a 5x. Make sure that you're rewriting every single one as minus. Bless you. For this problem, I have x's and y's. So I'm going to go through as a combined like term. So I'm going to have to identify the things that are exactly the same. So I go through and I see that there is one x to the third. Is there any other x to the thirds? Okay, I have a y. Is there anything else that's just a y? No. I have a 2x and a 3x. Those things can get put together. So I have a 2x and then a 3x. That's it. Yeah, that's it. You've already done this skill before. We're just doing more with exponents. And then I see that I have, yeah, this is not really new. We've done it. There's other things on here that are new, but a lot of this is review. So I'm going to start with the highest exponents. I have a -5x to the third, a -6y to the third, a 6y, and now I'm going to combine like terms. So I have a 2 minus 3, which is a -1x. Well, because it is plus. Okay. And then the other thing that I can combine is the -5 and the -3, so I have -8. Name something you might accidentally leave on all night. I put AC. That'd be awful.
Raise too many more points. A tree, you can accidentally fall off a tree. No. Oh, you might leave off. I thought it said fall off. I don't know why. I wasn't looking at it.
Oh my gosh, that's so silly. Name a breed of dog that would never scare away a burglar. I agree with that. Tell me something all little kids hate.
Vegetable schools, like it's more.
Besides a person, name something people hug. Name an animal with long ears. When someone says, I'm just going to have one, they mean
Beer.
I was gonna put Chihuahua, I just didn't want to spell that. This was good. Well, y'all beat the other class, 1330.
Still didn't beat the original record, which was like 1700 something. I think it's 1770 something.
Pretty good start.
So bad. What's birthday?
They didn't play today. We didn't have enough time. Pre-cal had lots to do. Mhm. All right, the next problem, simplify, rewrite without any grouping symbols or negative exponents. So for this first one, we're gonna go bit by bit. So these coefficients, we're multiplying. So it's 3 times -4. We're multiplying, so we get -12. And then for the x's, when you multiply coefficients, what are we gonna do with the exponents? Add. So we have 7 plus 2, or to the 9th power, and that's it. For the next problem, I need to distribute in the 3, exponent of 3 to everything. So as I do that, I'm going to rewrite all the pieces. So I'm going to get -5 to the 3rd power. X, 3, when I have something raised to a power, I multiply. So 3 times 3 is 9. 3 times -3 is -9. Z, 2 times 3 is 6. Now I need to check some stuff out. So negative times a negative times a negative. Anytime you have an odd amount of negatives, your answer will always be negative. So Sid was right. It's going to be a -15. X to the 9th. The next 9 exponent is negative, so I have to rewrite that as a denominator. And then Z to the 6th power. So again, I have a negative exponent, so I can fix that by rewriting it as a denominator. For the next problem, I have y on top, y on bottom, and I'm going to rewrite it a little bit bigger. And this is the same thing as y to the 1st power and z to the 5th power. So I'm looking to see which one has a bigger exponent. So here 2 is bigger than 1, so I subtract, and this 2 is going to go up there, and I subtract 1. For the z's, the z is bigger on the bottom, so I'm going to subtract 3 on the bottom. So when I rewrite that, the y is going to be up on the top, so the y is going to be up here on top, and the z is going to be down here on the bottom. So I end up with y to the 2 minus 1 is just to the 1st power. And then I get z 5, 4, 3, 2 to the 2nd power. So even if you feel pretty confident about doing exponents, these are just a little bit new. It's going to be good for you to go through and continue to practice these with me. For the next problem, I'm going to be doing the same exact thing, but I've got to distribute in that 2 to everything on the top and everything on the bottom. So first I have to rewrite it. So I will end up with 6 to the second power. Anytime I'm raising something to an exponent, I multiply. So I have 14. Negative 3 times 2, so negative 6. 4 squared. M to the negative 2. N to the negative 10th power. So now I'm going to go through just like I did before, that I'm going to look at the m's on top and bottom and the n's and see which one's bigger. For this one, 14 is bigger than negative 2, so I'm going to subtract. What happens when you subtract a negative? It's like minus minus. It becomes plus, yes. So for this one, since it's already a minus, minus minus becomes plus. Which one is a bigger number, negative 6 or negative 10? Negative 6 is closer to 0, it's bigger. So I'm going to subtract negative 10, which is the same thing as add 10. So I'm going to rewrite this. What is 6 squared, or 6 times 6? 36. And then I have m 14 plus 2 is 16. And n 10 minus 6 is 4. On the bottom, what's 4 times 4? 16. Can we reduce this? 36 and 16. How many times does 4 go into 36? 9 times. How many times does 9 go into 16? Sorry, 4 go into 16. 4. We have 2 more problems that we're going to do. This one, it's a division problem. And to do it, I'm going to split it up into 3 different fractions because there's 3 different things on the numerator. We've already done this problem, so this should feel like a review. We have already done this exact type of problem. So I'm going to split it into 3 different fractions. So all I'm doing is rewriting the numerator. So I rewrote the numerator with the 3 different terms, and then now I'm going to divide it everything. So I split it into 3 different fractions. So now I'm going to take each individual fraction and I'm going to reduce it. So as I reduce them, I'm looking at the numbers. So 24 divided by 8, and I'm looking at the values here. That one's actually pretty nice because anything over itself is 1. So what is 24 divided by 8? 3. And then I have anything over itself is 1. And then I have the y's. 3 is bigger, so I'm going to subtract 2. So I get y to the first power. So that's the first term. Then I'm going to subtract. And then I go to the next one. What's 32 divided by 8? 4. And then I'm going to start looking at the exponents. So 2 is smaller, so I'm going to subtract 2. 2 is smaller, so I'm going to subtract 2. So I get x, 5, 4, 3, x to the third, 6, 5, 4, y to the fourth, plus, what's 16 divided by 8? 2. And then I have x over itself. And then this one, I'm going to subtract 2. That is a problem that looks really, really scary. Let's not get that problem wrong on the quiz or on the test. It looks scary, but it's not super difficult. The very last problem that we're going to do, we're going to use a box for this. So what it means is that I'm going to have 2 terms on the side and 3 along the top. So I'm going to put x and then minus 4, x squared plus 3x plus 5. And I'm just going to multiply each one of these things in. So I get x times x. When I'm multiplying, I add exponents. And so that's like to the first power. So I get x to the third. Here I get negative 4 times x. So this becomes negative 4x squared. Here I've got 3 times 1. So it's 3. And then it would be x squared. And you can put these in any order you want to. You can go across and then across. It doesn't matter. 3 times negative 4 would be negative 12x. Five times x is 5x. And then 5 times negative 4 would be negative 20. Now I can combine like terms. So when you combine like terms, you can always combine diagonally because I see that I have an x squared and an x squared. I have an x and an x. I don't have anything to combine in the first or the last box. So I will combine these things and rewrite it. So this turns into x to the third. I have 3 minus 4, so negative 1 or negative x squared. Negative 12 plus 5, so negative 7x, and then minus 20. And that is it. So what I'm going to have you guys do, let me stop this and then I'll tell you.